then y2 will get the value, then y3 will get the value, like this. You understand? And this is called blocking assignment. Blocking. Block means like a car is coming, I block the road. It cannot go. Like it's like going. If I put something here, it cannot go. It cannot go. It's called block. I am blocking the way. I am blocking the way. Block has many meanings. Block has many meanings. Okay, one of the meaning is you are block the road. Block the road. You put something, so it cannot go. So remove block, it can go. It's called blocking. Block has other meanings. Like one of the meaning is box. Another meaning can be like an area. High. Say
neighborhood.
not exactly high, but it's smaller. Block by block. Like for example, say
building.
like we have roads like here, right?
مقاطعة in Arabic.
Say here we have some buildings, right? The highest full area is high.
مقاطعة.
It's called what?
مقاطعة.
Muqata'a.
You
You understand what is
parts of height.
Yes. It's like here you have 4 roads and you have some buildings here, huh?
Yes.
No road inside. No road inside. Like block, right? Block. You understand?
Yeah, yes,
This is one of the meaning of block. We say, where is your how to go to your house? You can say 5 blocks away. What is the distance of your house? 5 blocks away. So they know, okay, how much distance.
We can say on any building it's on a block.
It may be
Yes.
if you make a big building with this
Yes.
size. Normally when the design area, they make like row and column. Houses in rows and columns. Roads like this, say these are the big roads and these are the small roads. Huh?
Yes.
And again roads are here. So some buildings here, some buildings here, some buildings here. So this is a block, this is a block, this is a block. Maybe we have 10 or 15 blocks. Together it is a area. It's a neighborhood.
We can say one from many.
Just like that. So by the way, this is not what I am talking about, the block. Here it's another meaning. Here it is put something, you cannot
Close them.
close. Okay. So this is called blocking. And this is the opposite of blocking. This one is the opposite of blocking, non-blocking. Non-blocking. You know this thing, right? If you put a non,
Not.
it means not.
Not.
Not. Like your bar, right? Like your bar.
The opposite.
Blocking bar, huh? Blocking with the bar. But there is no such word in English, blocking with the bar. So you have to put non-blocking. Anyway, so non-blocking means this. If we do not have many, let us see. We have non-blocking. Non-blocking, we do not have examples. This one means that if you have like say y1, say d1, y2, say d2. Non-blocking means y1 and y2 will get their values at the same time. Okay. Blocking means if it is blocking, first y1 will get his value, then after y2 will get his value. Like y1 will block y2. You understand? y1 will block y2. y1 finish, go. y2 finish, go. Like this, block. But if you put it like this, it is like parallel. Parallel.
You can't do both.
Yes, this one will calculate at the same time. At the same time. Okay. And this one is always, assign is always non-blocking. Always non-blocking, and you write it outside always. Okay. Assign will come outside the always. Okay, it is always non-blocking. Non-blocking. Here these two will come inside always. Inside always. This kind of assignment you write for combinational circuits. Combinational circuits.
Step by step.
Yes, it will go step by step. Combinational circuit. For non-blocking, you use it mainly for sequential logic. Sequential logic. At the same time, like at the clock edge, you have the edge, everything happens like this. Huh? So this is the difference. We have a slide. We have a slide that talks about all these things. We have a slide here. We have a slide, blocking and non-blocking assignments, and that talks about the examples. Let's talk about the examples. Okay, rules for this. When to use non-blocking, when to use blocking. We have this. So let us talk here. So these are all blocking. So y1 will get the value, then y2, then y3, then y4, then y5. Okay. This is another example of using always, but here we will use another thing called case. Okay. So let us see these two examples and then we can finish. So you know 7-segment display. Did you see 7-segment display?
No.
You did not see? No, you saw. 100% sure you saw. Why?
What is that?
This is called 7. I'm saying, did you see 7-segment display? Did you see this one anywhere in your life? Did you see it?
What's the meaning?
Now I will draw it and you will know that you know actually. It says did you see something similar? These are the lights. So did you see this one?
What is that? Light?
All of them, each segment, how many segments? 1, 2, 3, 4, 5, 6, 7. 7 segments. Each of them actually light. So if you only use
Send the timer.
if you will only use this, this and this, you will get 7.
Excuse me. Send the timer.
Okay.
Like in the traffic light.
Yes.
They have
the
the
timer
numbers.
also.
It is 7-segment display.
7-segment display.
Yes. This time when you drive today, if you find any light, go close and see. This is 7-segment display.
Some of the clocks like this.
Yeah?
Numbers clock.
Yes, 7-segment display. Also like you know in our passage here and there, it's a moving thing.
Screen.
Screen.
Yes.
This is also this kind of things. It may have more segments.
Circle.
It may have more segments, maybe more than 7, but the idea is same. You understand? Idea is same. Like this kind of things, it is used everywhere. Like in your calculator.
Yes.
The calculator screen, same thing. They have some segments. By coloring them on off, they make different numbers. Different numbers. Same thing. So this is a very interesting thing. So actually, in some courses we have projects to make 7-segment display. To make projects, you will type in the computer 1, 2, 3, 4. It will come in the segment.
Like a memory.
Like a memory. Like also we used to make projects of making this like display. Like when you go to the bank, says right counter,
Yes, yes.
ticket number, and sometimes say wait, it come like this. Thank you for waiting. Okay, moving words. All of them are same thing. All of them are same thing. So you do not know, but in your everyday life, you are using many things from your computer stuff. But it looks like you are getting this from your childhood. No, someone is making this. Someone is making this. So everywhere is this engineering stuff. Everywhere is this engineering stuff. You cannot flee. You cannot flee. So here is a code for making this segment. Okay. So the idea is, you do not have a picture. No. So the idea is, we want to have a circuit. Okay. We will give the data. Data as an input, 4 bits. We will give a 4 bits data as input. Okay. And we want to send here 7 bits. Okay. Say for each segment 1 bit. One means say this is the first one. So 1 means make it say high, make it light. You understand? Suppose
0 of 1.
yes, say this is 1, 2, 3, 4, 5, 6, 7. Okay, suppose
Just in 8, it's open all.
say if you send say 0, 1, 1, no, say 1, 1, 1, 1, 0, 0, 1. If I give output this, then actually we are making 3. The first one is with this because this is number 1, segment number 1.
Yes.
So 1 means make this high. So I will make this one high. These are, you can think about lights. These are lights like diodes. If you give input, it will give you light emitting diode.
Okay.
Like bulb. You can think it is a bulb.
But
This lights. Tube light. So turn on.
okay.
1, turn on. 1, turn on. 1, turn on. 0, no. 0, no. 1, this one, on. So what is this? 3. So to show 3, you need to give this kind of output. Here I am saying this is 1, this is 2, but it depends on your system. Do you understand how you number them?
We can say 9, fourth one, 0, 1, 1.
Yes, to make it 9,
Yes.
you need to remove this, and put like this. If you want to make a 9, so you will give 1, 1, 1, 0, 0,
With this one.
1, 1. Right?
Probably give the
For-
last one.
This one?
I think yes. I think it's
Come.
Yes, sometimes
Yes,
this is
9.
also 9. Yes.
yes.
This is also 9, this is also 9.
Excuse me. For 8 all 9.
Yes. For 8, you have to give all 1.
All 1.
So, this kind of thing, we need to type here, say 1, 2, 3, 4, whatever we want to type. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And here we want to generate bits that will make this one. Okay. So here module 7 segment input 4 bits data, output name is segments 7 bits. and it is called also red because inside the always on the left side. Okay, always at star, that means every time it will happen. Now the output will depend on input, right?
Yeah.
Output will depend on input. Whatever, if you want to give 1, it will give one sequence.
Yes.
If you want to write 2, it will give another sequence. Like if, right? If 1, give one thing. If 2, give another thing. If 3, give another thing, right? It's like if. Now, those who already know C, you know that the thing of big if you can do using case. Those who have taken C, there is a statement, there is a keyword called case in C. Here also we have the same case. Case, and inside the bracket, data means look at the data. Yes, the value data, and based on the value do something. So case data, then see 0, 1, 2, 3 up to 9. So if you give, say, data equal to 6 here in input, if you give 6, what will happen? Then there is a 6 now here, right? 6.
Yes.
So the program will jump here. It will not execute all of them. It will execute only the line with this value 6. So if you give here 6,
3, 4.
it will jump all 0 to 5. It will jump. It will not execute. It will jump to 6,
Why is
and then it will do it. So like a remote control. What remote control will do?
choose any number?
Oh, you mean Chris 2, it will work for 2 only. Yes, something like this, yes. Something similar.
Teacher, here 9. Say 1, 1, 1, 1, 0, 1, 1. It's different. Here.
No, I mean it depends on how you number the segment. That's why I'm looking for their picture. It's not here. It depends on how you number your segments. Do you understand? I numbered this way. Here maybe they numbered, let's say 9, right? So 1, 1, 1, say 1, say 0. No, okay, same. Their 9 is like this. If you make this, it will be right.
Yes, sir. If I choose here case 9,
It will jump in the 9.
What?
Then output 9, then see there's a colon. Segments, this segment is the output equals 7-bit binary, and the number is
7.
7. Remember this one we saw
This is appear
in the output. It will output. Now these are not circuit. These are lights. Normally it can be light emitting diodes, different diodes. You put in the board. Now you take the connection and put it here. Each bit you put the connection. Do you understand? These are separate things, hardware, like diodes. Now the circuit, here you type, say in the computer you type. This one will give you the bits. This program, circuit will give you the bits. Now say you have 7 bits. 7 bits. Now you take, say, bits, connect here, take next bit, say connect here, okay, to the diodes to give the input.
Why is happening here to 9?
No, here your input is 4 bits, but the segment can display from 0 to 9. 7 segment display can display from 0 to 9. So input is 4 bits, but with 4 bits how many values you have?
4 bits. We have 15.
From 0 to 15, 16.
16 bits.
From 0 to 15.
15.
So the 7 segment can display from 0 to
2, 3.
9, right? 0, 1, 2, 3 up to 9. Actually, you can display others like A, B, C, D sometimes. But say we only want to display numbers. Okay. So how many we have here? 10, right? So 10, 11, 12, 13. 6 more is left. Right? With 4 bits. You can have 0 to 15. We use 0 to 9. So if you give your data, say 12, what will happen? Yes. So if you give here data 12, it cannot show 12, right?
Yes.
So in that case, what to do? So we have something called default. See, from 0 to 9 we have, and we have a called default. Default colon segments equal to all 0. All 0 means blank, nothing, huh? No output. So default means if the value here does not match any value from here, then this line will execute. You understand? If you give data equal to 12, do we have 12 here?
No.
No, we do not have 12.
Okay.
We have from 0 to 9.
9.
So that means in this part there is no 12. So the program will jump to default. Default means default. The word default means if you do not have any special things, you will do this. This is called default. Like for example, say in his stove,
Okay.
this button in his stove
Yes.
is white or transparent.
Okay.
Now, is there a rule? Is there a rule that the button should be transparent? Is there a rule?
No.
I mean, is there a rule, fixed rule that his button must be transparent and white? There is no rule, right? You can tell the tailor, I need a red button. In the
Of the
white
customer.
stove, yes, the customer can tell, I need a red button. And he must make it, right? He's paying. There is no rule in Saudi Arabia that says, no, you cannot have a red button in. So, is there a rule? I don't know. Is there a rule that you cannot have a red button? You cannot have? There is no rule, right? Okay. So, our example is valid. If there is a rule, then we need to give another example. So if you tell him that I need a red button here, he will give you, right? Now, how it looks, it is good, it is bad, it is up to you. You are paying him, he will make it. Now, when you go to the tailor, do you tell him the color of your button? Do you tell him?
No.
You do not tell, right?
Yeah.
Does he ask you? No. Why? Because the default is this. Default in his mind, the default is the color white. But if you have specific, you will do with specific, right? Like you don't have, possibly you don't have here, but sometimes we have some these buttons made of wood. Wood.
Wood.
Yes. Wood. These things. Very nice. This small but not plastic. These are of plastics, right?
Yes, it's a plastic.
So it can be wood. Okay, nice looking of type wood. Okay. So in that case, you need to tell. Actually, sometimes yes, sometimes you can tell. I need buttons with wood. Sometimes you can tell I need button with plastic. Okay. But here you are not telling. If you do not tell, the default is white. Do you understand the meaning of default? Here. So here, if there is no value in this range, the default is all 0. Like for your button, say we have two colors. Say now so many Qasim University students, they wear red button and white button. Suppose after a few years we have so many students they wear red button or say red and say green. Red button and green button. So and default is white. So when you go to the tailor, he will ask you, do you need red button or green button? Say red means College of Computer, green means all other colleges, and white button means you are not in the university. Okay, you are not in the university. So he will ask you, do you want red or green? So if you do not tell him, what he will do? He will make white, default. But if you tell him green, he will make green. If you tell him red, he will make red. If you do not tell him, he will take the default. Default is white. So here, if you do not tell these values, default is all 0. So all 0 means blank. Nothing is there. As if you give a value out of range. Okay? So this is called default. So we'll see these things after.